Okay, well, let's kick things off. Good morning or good afternoon, everyone, as the case may be. My name is Phippe Tortell. I'm a professor of oceanography at the University of British Columbia in Vancouver, and I'm also the editor of the recently released book, Earth 2020, An Insider's Guide to a Rapidly Changing Planet. I'd like to thank all of you for joining us, and I would also like to thank our hosts at Dartmouth University. Elizabeth Wilson, who's one of the contributors to the project and a professor at Dartmouth, is unfortunately experiencing some technical difficulties with her connection. She may hopefully join us in a few minutes, but I will kick things off. And I'll also acknowledge Stephanie Garcia, who you will see perhaps in one part of your screen, is going to assist us behind the scenes, but very importantly, moderating questions. And she'll be sending some chats to the group, reminding you that if you do have questions after our panelists have finished, to send them to her, and she will sift through them quickly, fire them over to me, and then I will pass them out to our panelists. So the purpose of today's session, which will last exactly 1 hour, is to give you the opportunity to hear from and then to engage in questions with 4 wonderful authors who contributed chapters to the Earth 2020 volume. We have done one prior session of this last week, I think it was, and we have recorded that, and we can pass around the link for those who wish to see it. In that session, I gave a few-minute introduction to the book project, and I'll refer you to that recording to get more information. And for the sake of brevity, I'll just a few remarks about the books and then very quickly pass it on to our panelists. As all of you know, I'm sure this year marked the 50th anniversary of Earth Day, and following on several other book projects that I had been involved in, I had decided to tackle this one, as I did with the other topics, from a very multidisciplinary and cross-cutting perspectives. And I had the good fortune of assembling a wonderful group of authors, 4 of whom you'll hear from in a moment, to give their own perspectives and reflections on what that anniversary meant. Specifically, I asked each of them to reflect on how Earth's biophysical or social or legal or political systems had evolved over the 50 years since first Earth Day in 1970, and then to draw on their own experience and perhaps a little bit of imagination as well, to make some predictions and perhaps some aspirations of what the future may yet hold if we are to listen to the best advice currently available. And so today we'll hear 4 different authors who will present their own perspectives on forests, on fisheries, on the accumulation of plastics and other debris, and on the potential for geoengineering approaches going forward. So without further ado, I would like to begin the panel. I'll introduce very briefly each of the authors. They'll speak for about 6 minutes. We'll go through all of the authors in turn, and then we should have a lot of time for some interactive questions and discussion. So it is my great pleasure to first introduce Professor Sally Aitken. She is a professor and associate dean in the Faculty of Forestry at the University of British Columbia. She's also the director of the Center for Forest Conservation Genetics. Professor Aitken's research integrates genomic and climatic data as she tries to understand processes driving local adaptation to climate in trees, and also to understand how forest management will help us assist the adaptation to climate change. So with that, I'll ask Professor Aitken to start.
Okay, thanks very much, Philippe, for that introduction and for including me in this book project. I've been reading the other essays during the isolation that we're all under right now, and really taking away a lot from them. So thanks again. It's been a great project to be involved with. So trees and forests have both long been symbols of environmental movements around the world. And I think that all of us now in some degree of isolation and suffering some level of stress due to the COVID-19 situation can really appreciate the effect that a walk in the forest has on our mental and physical health. And we have a lot of other benefits from forests as well. They provide us with clean water, clean air, habitat for about 80% of the biodiversity, the terrestrial biodiversity on Earth, and many other ecological services. Trees also produce wood, and wood is a low carbon material, a low carbon footprint material. and we can't have wood and wood products without harvesting forests. So we've got this conflict between forest standing and using forest products. And at the same time, and especially since the first Earth Day, forests are shrinking in area globally. Many forests have gone from being carbon sinks to carbon sources. And climate change is impacting the health of forests that remain in many ways. So the thing about trees is they live a long time. They live long, slow lives. And on our human time scales, they can seem stable and permanent. You see big old trees and it seems they've been that way forever. But we are seeing the lives of many trees cut short by climate change. So at higher latitudes, we've had huge insect outbreaks that have been facilitated by warming. It used to be that freezing winter temperatures would keep many of those insects in check, and that's not happening to the same extent. We're also seeing drought mortality and seeing extensive wildfires that are becoming both more common and more intense. And so those disturbances are really altering the carbon balance and the health of forests and changing the composition of forests in many places. And where you find a particular forest type or a particular species is largely determined by climate. And the ranges of these species can only shift slowly compared to the velocity with which climate change is moving. So we've got this shifting of the places that trees are best suited to compared to where they actually exist. Now, humans are accelerating climate change through deforestation. And currently, deforestation is responsible for about 18% of greenhouse gas emissions. Only about 50% of tropical forests remain globally, and about 20% of the Amazon has been lost since the first Earth Day. And it's not like the rest of the world, other than the tropics, hasn't undergone deforestation, but much of that happened farther in the past, and many of us live in places that were previously forested. Much of the deforestation currently is being driven by cheap agricultural commodity products that we consume many of in all parts of the world. And there's a real fear that this deforestation and burning specifically in the Amazon is going to alter the local climate in that area, replace rainforests with arid savannas, and in turn affect global climate patterns. So we've got this feedback between the climate and forests that humans are altering. But we're also relying on forests to slow climate change, and there are countries and companies and individuals buying offsets that are thinking that all we need is trees to absorb the extra carbon emissions that we're putting out into the atmosphere. And in fact, forests and other terrestrial vegetation have absorbed about a quarter of the carbon dioxide that's been released by human activity in the Anthropocene. So an amazing statistic to me is that forests and the trees and the soils store more carbon globally than all of the readily exploitable oil, gas, and coal reserves. So there's a remarkable amount of carbon in forests, and those forests can take up carbon. But the problem is, one of the many problems is that we maybe we could just plant all these trees, but there isn't sufficient capacity to do that. Now, there was a recent study that got a lot of press that said there's room on Earth for another 500 billion trees. And that was based on satellite imagery. But the problem is that when you zoom in from images from space onto the ground, you find that that land's being used for other functions. It's being used by local communities for other purposes, and that it's extremely challenging to undertake that kind of reforestation, really, really impossible. It needs to involve local people, and that land is being used for other purposes. So unless trees are worth more alive than logged, we're not going to have more trees on the planet. At the same time, wood is a great substitute for many carbon-intensive products. There's a big trend in building tall buildings out of wood that have lower carbon footprints than buildings of concrete and steel. We've got the development of bioplastics that produce packaging, biodegradable packaging from chemicals found in wood. And to understand the trade-offs between forest standing and absorbing carbon and using these products, we've got to assess carbon across the whole value chain, from the ecosystem to the product and beyond, what happens to that product after it's used. So what are some other solutions? Certainly planting trees is a good thing, but it's not going to get us out of this mess. So there are other things that we can do to improve our environment. Increasing tree cover in urban areas is really important. It helps adapt urban areas to climate change. It helps cool them, helps mitigate some greenhouse gas emissions, and it has a big effect on human health. So in conclusion, we are still, after 50 years since the first Earth Day, very dependent on forests for many things, but they can't save us from climate change. And in fact, we can't save them from climate change unless we undertake the systematic societal changes that we need to our energy systems, our transportation and food production systems to slow the pace of climate change. And if we don't do that, we are not going to have healthy forests that can continue to sequester and store those vast amounts of carbon and provide all those other ecological services. Thank you.
Okay, thank you, Sally. So we'll segue now very nicely, I think, into Doulas MacMartin, who will tell us a little bit of his thoughts around geoengineering. Doulas is a senior research fellow in the Sibley School of Mechanical and Aerospace Engineering at Cornell University. His work focuses on climate engineering with the goal of helping to develop knowledge necessary to support informed societal decisions around the challenging and controversial field of geoengineering. Go ahead, please, Doulas.
All right, thanks very much. And thanks again for including me in this book project too, which has been a really fun project and really educational for me as well, reading all of the rest of the chapters. So I'm going to talk about geoengineering or climate engineering, which for good reason is a rather controversial subject. I think it's a really important conversation to have, but I'm not actually going to start with geoengineering. I'm going to start with talking more about climate change, cutting CO2 emissions, and where we are in that challenge. And just to tie this back to Earth Day, if we'd started doing this 50 years ago at the first Earth Day, then climate change would be completely behind us now. Unfortunately, of course, we didn't. So we have to cut CO2 emissions, and cutting them isn't good enough. We have to get them to zero. But there's a couple of problems in thinking that that's the only thing we need to do. The first is that CO2 lasts a really long time in the atmosphere. From societal perspective, it's practically forever. And so the day that we get emissions to zero isn't the point at which we've solved the problem, it's the point at which we've stopped making it worse. Kind of like realizing you're about to get into a car accident and hit the car in front of you. The very first thing you should do is take your foot off the gas. It would be pretty crazy not to, but don't expect that to solve the problem by itself. The second thing is that cutting emissions all the way to zero is actually pretty hard. That's not just a political problem, it's technically hard as well. So we know lots of things we could do that would reduce emissions relative to today, but reducing isn't good enough. We actually have to get to zero, and we have to do that everywhere on the planet. And that's simply not going to happen overnight. But what we really need if we want to avoid significant climate change is to get CO2 emissions to zero practically right now. And then the third thing is that there's actually lots we don't understand about the climate system. And in particular, even if we just stopped emitting, if we stop burning all fossil fuels everywhere on the planet tomorrow or over the next few years, which simply isn't going to happen, that might still not be good enough. So I actually think myself, that's actually one of the biggest confusions I see when I talk to people about climate change. This is not just a matter of powerful political forces standing in the way of things like renewable energy. That is true, and we do need to fix that. But even when we do, there's actually going to still be a little bit more to do. So if I go back to the car accident analogy, but the next thing you do after you take your foot off the gas is you go put your foot on the brakes. And in the climate context, that's like pulling some of the carbon dioxide back out of the atmosphere that we already put there. And in fact, the only reason that you see any news stories that say, oh, we need to get to zero emissions by mid-century, rather than saying we need to do that right away, is that all of those scenarios have built into them the assumption that after mid-century, we then go negative and pull out more carbon dioxide than we put in. And the challenge right now, or one of the challenges, is we actually don't yet quite know how to do that. So as Sally Aitken, you just heard, planting trees can be a part of that problem, but we didn't create our climate change problem simply by cutting trees down. We created it by digging fossil carbon out of the ground, and you shouldn't expect that simply reversing those land use changes and planting trees in places that used to have them simply isn't going to be enough. And that's basically true for any of the more natural sounding solutions. So on the positive side, there's lots of ideas on how to pull carbon dioxide out of the atmosphere. On the downside, right this instant, there's no option that we know how to scale sufficiently that doesn't have other environmental impacts and that's not incredibly expensive. That's all going to take research, and finding a solution and then implementing it at the scales we need is going to take time. And what all this really means is we don't currently have a strategy that guarantees a future without climate risk. So in that sense, we're already gambling with the climate of the planet. So if you know you're going to hit the car in front of you and you don't yet know whether your brakes are good enough, you might actually want airbags. And you would never sit in your car and just sit in the driveway and set off your airbag for fun. And you'd certainly never say, great, I have airbags, I don't need to take my foot off the gas. And that's the analogy you should keep in the back of your mind when you think about geoengineering. So what people typically think of when they think about the word geoengineering is ideas like putting aerosols, so these are just small particles or droplets, really high up into the Earth's atmosphere, so up into the stratosphere. That's much higher than where aircraft fly. And if you put them high enough, the atmosphere is stable enough that the aerosols stay there for a year or more. They reflect sunlight and that cools the planet. And we know for sure that it would cool the planet because nature does this for us every now and then. So in 1991, for example, Mount Pinatubo in the Philippines erupted and added sulfate aerosols to the stratosphere, and that cooled the climate by something of order of 0.5 degrees Celsius. So in principle, you could do that without all of the ash and other problems of volcanic eruption, just by flying aircraft. The aircraft that can get high enough don't exist today, but it doesn't seem like it's fundamentally hard. And in fact, one of the concerns is that this is potentially so cheap that it would be too easy of a solution. So I'll just try to wrap up quickly here. There's concerns if somebody ever did this on both the physical climate side and the societal side, and where there's real issues on the former. To be honest, I think it's actually the societal concerns that are a little bit more challenging. Partly that's simply because the physical impacts of climate change are likely to be worse. And so there's really just two big questions, or two. One is, how do you make decisions about something that affects everyone on the planet? And second is, how do you make sure that this isn't just taken as an excuse not to mitigate? So if we'd, like I said at the beginning, if we'd done this 50 years ago, if we'd been addressing climate change 50 years ago, we wouldn't even need to be thinking about these ideas now. And let's just make sure that when we get to the 100th anniversary, 50 years from now, that climate change is behind us then.
Okay, thank you very much, Douglas. Now moving on the theme of wastes in the atmosphere and the Earth systems, I'd like to introduce Professor Roland Geyer, who is a professor of industrial ecology at the Bren School of Environmental Science Management at the University of California, Santa Barbara. Professor Geyer studies the relationship between environmental performance, economic viability, and technical and operational feasibility of pollution prevention strategies. Go ahead, please.
All right. Thanks, Phippe. Yeah, so Phippe asked me to write a chapter about plastic, which I started studying about 10, 15 years ago. And I guess plastic could also be considered a symbol of the environmental movement, but sort of in a negative way. Doesn't usually get a good reputation. And plastic is increasingly also being used as a kind of environmental indicator of the environmental impact that we have, that society has on the natural environment. And in particular, of recent interest is plastics in the ocean, also called plastic marine debris. And so we had a working group working on this, and 5 years ago, we came to the conclusion that in just 1 year, that was 2010, several million tons of plastic probably have entered the world's oceans. So somewhere between, there's big uncertainty, obviously, this is a modeling result, not a measurement, somewhere between 5 and 13 million metric tons. And everybody was just stunned by that sheer amount of plastic that we think entered the ocean in just 1 year. So that would happen every year. It certainly has not gotten less since then. And so that was a stunning result. And one thing I would say in order to think about the 50 years of Earth Day, that I'm pretty sure actually in 1970, there was literally no plastic in the ocean. And the reason I'm so sure about that is that actually we produced very little plastic back then. So the stunning thing about plastic is that it's a very new, a very recent material. Most people now put the start of plastic production right around 1950. So actually just 20 years before the Earth Day. So we actually have production statistics that go all the way back to 1950, and global annual plastic production in 1950 was right around 2 million metric tons. In 1970, it had grown to 37 million metric tons. So a big growth, but if you think that 37 million metric tons of plastic, virgin plastic produced in 1 year is a lot, then think again, because by 2017, annual plastic production has grown to 438 million metric tons. So like an 11-time increase in annual virgin plastic production just in those 50 years since the first Earth Day. And once we realized just how much plastic we make year over year over year, and everyone else, then it becomes less surprising that a couple of million metric tons might end up, or probably end up, in the ocean every year. It's actually not. It's a leakage of like a minor fraction of that total amount of plastic that we produce. And so yeah, and plastic production really started only 70 years ago. What that means also is that plastic has actually been proposed as a stratigraphic indicator of the proposed Anthropocene, because if you do digs in the say sediments, like ocean sediments, like they did off the coast of San Diego, you find plastic in all the layers right up to 1950, and then it disappears. And they also found that plastic concentration in the sediment layers doubles roughly every 17 years. So that's kind of where we are in terms of plastic, and what should we do about this? So recycling has always been sort of the go-to in particular solution, in particular here in the US. And I don't know if you've heard of it or even seen it already. There's an interesting documentary that just came out in PBS and Frontline Corporation. It's called The Plastic Wars. And amazingly, they actually have executives of the Plastic Industry Association on camera saying that the industry always doubted that recycling plastic would actually work on a large scale, but they promoted it anyway in order to take the environmental pressure of plastic. So even the industry never really believed in plastic recycling. And of course, now with the national sword policy, China refusing to take our difficult to recycle plastic waste, and now Southeast Asia following suit. So we're in a big pickle in terms of plastic waste management, and recycling doesn't seem to be working. One other, Sally mentioned earlier, biopolymers as sort of a solution. So there are major concerns surrounding biopolymers. First of all, bioplastic, a lot of bioplastic that is currently being produced is actually not biodegradable. It's just sourced. So it uses biomass as a source rather than fossil hydrocarbons, but it's actually still not biodegradable. So one example is the plant bottle of Coca-Cola. It's still PET #1 plastic. It won't go away like in 50, 100, more, several hundred years. So that all just leads me to the conclusion that really the one thing that we urgently need to do, and this is actually not just about plastic, but it's about all materials, is to make and use less. And that is actually the only, it's obviously it's the simplest approach to sustainable materials management, but for some reason it's the one that gets talked about least. I actually think we could easily halve our use of plastic, and it would not, if we do it in a smart way, it would really not compromise our quality of life. Yeah, for some reason, even my kids in elementary school learn the waste hierarchy, or reduce, reuse, recycle, but then somehow we always forget the first two and jump to recycle immediately, and then are surprised if recycling doesn't work out. So yeah, that's sort of my message here, that I really think source reduction, using less, is urgently required. I'm not saying that recycling can never work, but I think just relying on it on its own is not going to work. I also think that biomaterials, just like biofuels, on their own will really not going to solve our problems.
Actually, Roland, I'm going to just jump in now because I want to leave room for questions. Thank you very much.
Absolutely, yes, thank you.
Okay, lovely. And finally, it's my pleasure to introduce my second UBC colleague on the panel after Sally, Professor Rashid Sumalia, who is a professor in the Institute for the Oceans and Fisheries, and also in the School of Public Policy and Global Affairs at UBC. He is also a Canada Research Chair in Interdisciplinary Ocean and Fisheries Economics, and he wrote one of perhaps the shortest titled essays in the book called Simply Fish. Go ahead, please, Rashid.
Yeah, that's a cute and short and sweet, right? But actually, fish connects to all the topics of today in various ways. So that's why I study fish. I think fish is more interesting, Sally, sorry, than trees, because trees don't move, and so on and so forth. But it's connected to forests, how well we take care of our forests, the interface between the ocean and the land. It connects to geoengineering. Climate change is huge for fish. And it connects to definitely plastic and pollution, marine pollution. So that's it. So now, when we got the invitation by Phippe, me and Daniel Pauli, we decided to provide a brief history of fish and fisheries. So that is the kind of angle we took. Before I get into the history, I thought I should quickly give you some numbers about how important fish is to millions of people around the world. It is food. I mean, fish is food. We take about 100 million tons of fish from the ocean, both legally and illegally. And that is the equivalent of about, 100 million mature cows, if you want to have a sense of how much we pull out of the ocean each year. So it's food, but it also means the ecosystem is probably under stress if you take so much biomass out of it. It employs a lot of people. We estimate about 260 million people earn some income around the world from fish and fisheries and the value chain of fish. And it turns out to actually have a huge economic impact. You'd be surprised. And all this, I'm talking about only marine fish. I'm not talking about agriculture or inland fisheries. In terms of money, economic contribution, we estimate about $500 billion of dollars pumped into the global economy. So this is really important. And I'm just talking about history. There are many other aspects of this. So the way I split my talk very quickly is to have into periods. So there's a period I call the naive beginnings of the relationship between people and fish. And historically, if you look back to the literature, actually, our relationship began where else than in Africa? Everything begins in Africa, isn't it? So fishing, actually, about 165,000 years ago, archaeologists have found, what is it? They have found remains of, shells of abalone in a cave in South Africa. And since then, there have been evidence of this. In about 90,000 years ago in the Congo, they were using sophisticated harpoons to catch fish. And so that is the beginning. But all along until the 1880s, actually, most of the energy used to catch fish is the muzzles of fishes and also the wind. So, and at that time, there was low demand, low population, low technology. People thought we could never overfish fish at that time. That's why I call it the naive beginning. And then we move on. After 1880, we had technology coming in. Steam-driven trawlers were developed in the British Isles, the home of the Industrial Revolution. This spread over in Europe and North America and the North Atlantic. And this actually started showing to the world that we can actually impact fish. So there began to be pressure on fish as the technology, population, and demand increased. So that took us to what I call the rude awakening period. That is after 1880. We actually realized that we can and we do impact fish stocks. This led to science becoming important, fisheries science, collecting data. And fisheries management started being introduced. The ICES, the International Council for the Exploration of the Seas, was established. The first international fisheries science and data collecting agency to be headquartered in Denmark, Copenhagen, began. And this spread to many countries. That's how we got our fisheries departments, even ministries around the world, all to help us understand. And then fisheries management came in, like quotas were decided, licenses were being given, and so on. So all this was going on, but they were quite narrow in their thinking. And this led to some spectacular collapses in the 50s through to the 90s. So we had the California sardines collapsing in the early 50s. We have the Peruvian anchovy in 72, the Norwegian spring spawning fisheries, and then the coast stocks off Newfoundland in the 90s. And that again led to a rethinking of our fisheries management, data collection, and so on. Because before now, the data was mainly about commercial fishing, as if the other parts of the ecosystem didn't exist. So we realized we had to think broader about the ecosystem. The data we collect is not only the catch of commercial fish, we're catching small-scale fishes, catches, illegal catch, discards. So all this, and we started thinking ecosystem-based management, more broad thinking. And so, and I think the collapses of the 50s, 60s, 70s actually helped to push for the FDA in what, 70 years ago. So that fish was part of that movement. So finally, to think about what to do and how to move in order to ensure a bright future for fisheries and to support the goals of FDA, we need to do a number of things. We are discovering that there's no panacea. We have to have proper science, broad-based science. We have to have interdisciplinary thinking because no single discipline can solve the fish problem. We need everybody on deck. You need to think broad. You need to have quotas. You need to have catches where it works, community-based quotas. You need to close parts of the ocean as insurance. Close the high seas to fishing completely, some of us advocate. And let us fish within country waters that we can monitor and control better, and so on and so forth. So there's new thinking, and hopefully that will save our fish and save our food and protect the jobs and the economy of millions of people around the world. Thank you very much.
Okay, thank you, Rashid and Sally and Douglas and Roland. We have plenty of time for questions. Let me just remind you, please, to send those questions directly to Stephanie Garcia through a Zoom chat. She'll be handling those as they come in and passing them on to me, and I will ask them. So I will open the floor. I have one question that did come directly to me that I'll pose in a moment. I'll just take a second, though, to reflect that we have a rather nice symmetry, I think, amongst the four panelists, two of whom, Sally and Rashid, have talked about the implications of overconsumption of resources, whether they're forest resources or fish resources, whereas Douglas and Roland have talked about, in some ways, the flip side, when we have the accumulation of excess wastes, whether they be in the atmosphere or in other parts of the Earth system. So it's an interesting two-sided look at humanity's impact on the planet. So the first question that I will read is for Doulas MacMartin. I'll ask all of the panelists to try to answer succinctly and quickly so we can have as much time for questions as possible. If the questions may be directed to one or the other, if others of you wish to jump in, please do so, but again, being mindful about time. So the first question is, Douglas says, we don't know how to take carbon out of the atmosphere, but what about using CO2 scrubbers? Solar energy would be a great way to do it, operating like trees, taking CO2 out during the day. Is it impossible to scale the technologies for scrubbers and solar to take out enough CO2 from the air?
That's actually one of the ideas that is definitely scalable. There's no fundamental limits. There's just a pure cost limit. That right this instant, the cost estimate for that sort of direct air capture is about $100 a ton. I think there's good reason to expect that that might get lower, but right this moment, you'd probably be better off using the solar energy to displace fossil fuels. The better way to actually do the direct air capture is to figure out how to do that with ambient waste heat from various sources. But that's definitely one of the options that shows promise.
Okay. Thank you. Moving right along. Next question for Sally Aitken. You mentioned that we likely won't preserve trees until they are worth more alive than as lumber. What sort of market instruments are available and effective in incentivizing communities to keep their trees?
Well, that goes far outside of my own area of expertise, but certainly there are carbon credit systems available for maintaining some areas of forest, and those are usually evaluated against what would have been done under the status quo. I think there are also ways in which forests can produce other goods and services that keep communities going. For example, through ecotourism, through forest products, through non-timber forest products, and things like that. But it's got to be, those things have to be valuable to those communities, and often those ideas will come out of those communities. So we need to be working with local initiatives.
Let me actually put Rashid on the spot a moment. He actually is an economist. Rashid, I know you work mostly in the realm of fisheries. Are you aware of any markets around incentivizing conservation in forests? You worked on that at all? You're mute still.
need, economists have been thinking a lot about it. I think the way Sally put it is focusing on the market value of the timber versus what you get out of the forest. But actually, many of us think about values in a broader sense. There are values that we don't necessarily buy and sell in the market, but they are very valuable. So you need to find a way to market this. People argue like ecosystem services, where you could actually pay communities that maintain their forests, because the forests do much more than just the timber, right? They sequester carbon. They actually provide a lot of services to communities. So that's, we try to find a way to internalize these other broader values, and that's the way you can do it. And then this is backed up by policy, actually. Policies can be designed because we know the value of the trees are more than the timber. And so you need policies to be put in place to support it.
So one has to develop slightly more explicit accounting systems that itemize values that have often been implicitly ignored.
Exactly.
Okay, so moving along, it's quite a broad question. Again, for Sally, others may jump in. The question is, how does our relationship with nature, in this case, forestry and wildlife, impact pandemics like COVID-19, and how can we prevent future outbreaks?
So I think that a lot of people are reflecting on how the COVID-19 situation is sort of a lens through which we can regard our impact on ecosystems, but also provides us with an idea of how quickly society can react to problems when they're recognized and when there is collective will to respond to them. Certainly the harvesting of the products, the destruction of natural areas, the capture of wild species in various ways for trade, for food. These are all issues that bring us in some ways into conflict with natural systems, and at the same time, of course, we're very dependent on all of the services provided by those natural systems. But there have been people discussing the imbalance of our relationship with nature, and how the coronavirus is perhaps one example of that.
Okay, we're waiting for more questions, but I have one that I've been quite keen to pose to both Roland and Douglas on the subject of wastes, in particular plastic waste versus CO2, both of course waste products, both of course derived from industrial activities. And in fact, plastics are very much linked to CO2 in that they are predominantly produced from fossil fuels, if I'm not mistaken. So my question is about the nature of attribution and liability for the production of waste in the context of assigning responsibility for cleanup. CO2 is obviously a very diffuse problem. We can track, though, the production of CO2 from various nations and industry. Similarly, we can track the production of plastics. So my question is there difference in the approach that can be used to assign liability and responsibility for cleanup in the context of plastics versus CO2?
I guess I would say, so you can certainly think of the CO2 removal as basically, paying money effectively, if you do it with something like direct air capture, to remove your historic CO2 burden. And while there's certainly uncertainty in the historic burden, it's not, I don't think it's, the uncertainty is not huge relative to the magnitude of it. Although there's certainly some difficulty in how you attribute, if we buy a product that was made in China, who's responsible for the CO2 that was embedded in that product and in the transport of it. So I think the challenges are actually much more in the international negotiations on that sort of thing. But I certainly think that's a perfectly reasonable thing to say going forward is, every molecule of CO2 any country emits, that country is responsible for pulling back out in the future.
Roland?
Yeah, I'd say when it comes to something like plastic, I mean, overall, the policy approach, I think, is called extended producer responsibility, or EPR for short. And the idea is, it's a concept that came out of Sweden in sort of the late 80s. And the idea is that producers of products should share the burden of their end-of-life management. Mm. And then so overall it's a relatively simple concept, and it's actually has been implemented in particular by the European Union with so-called end-of-life directives. So there's an end-of-life packaging directive, an end-of-life vehicle directive, and end-of-life waste electronic and electrical equipment directive. And so I'd say that it's very doable. The devil's in the detail is how exactly you implement that. I'd say the easiest would be that added to the price of a product or the price of the material is like a disposal fee that needs to get basically paid by the producers, and that money can then be used to manage the product at the end of life. So there's like one idea that is being circulated by some of my colleagues, is called Penny for the Planet. And it's basically, I think the idea is to charge the virgin polymer producers, plastic producers, a penny for each pound of plastic they produce, and use that money to better manage plastic waste.
Okay, thank you. Rashid, I see you have your hand up to make a comment perhaps on that topic.
Yeah, very good. Yeah, it's in theory, I mean, both can be regulated and taken care of. I think the big problem we have, as I see it, is that the distribution of the cost and benefit of these actions by whoever, by companies or countries, it's not distributed. It doesn't match. So some of us benefit by putting plastic in the ocean, and then some of us pay the cost. And this mismatch, I think, is quite a powerful constraint we have in taking action. And that is what leads to all the lobbying you see and all the pressure groups, the political forces. And to me, that is where the problem is, more than actually the theory of how to do this. We have economic theorists, whatever theories, to help us do this, but it is these forces within society that is the issue.
Thank you. And following up on that, there's a question from a participant, someone who's listening in for Roland again, asking how research on plastic, and perhaps your research in particular, has changed over the last 15 or so years.
Oh, am I unmuted? Yes, unmuted. Well, I think what's really interesting about plastic is that 15 years ago, plastic was already everywhere, but it did nowhere near attract the attention that it is attracting now. So I actually got into plastic research, so studying the flows and stocks of plastic in society, because there was so little research on plastic in my field, industrial ecology, 15 years ago. So I just started looking into it because it seemed like most of my colleagues were studying metals and other sort of industrial nutrients, as we would call it. And then once I realized how large the quantities are, and on what incredible growth trajectory we are, then I just got more and more fascinated. And for some reason, around the same time, the media really picked up plastic as an environmental issue. I'd say about 10 years ago, or even less than that. And I think for some reason, plastic in the oceans particularly resonates with the public, I think. And maybe it's just because it just looks and feels so wrong to pollute the oceans with plastic. And so there's a lot of research and activity that surrounds reducing and somehow mitigating plastic marine debris. And what I think is going to happen going forward is that we're going to realize that plastic in terrestrial environments is just as big a problem, and there's probably going to be a lot of work happening going forward in addition to mitigating plastic marine debris.
Yeah, I would actually add, as an oceanographer, I would add from my perspective, a big change in plastics research has been the recognition that microplastic, essentially very, very small bits of plastic, is incredibly important. The initial focus was on, for lack of a better word, the more charismatic pieces of plastic visible to the eye, but it's become apparent that a large volume by mass of plastic is actually largely invisible. And these are the kinds of things that get into fish gills, for example. And that's, from the oceanographic perspective, has been a really important change. The next question is for Rashid Sumalia about fishing. And the question is, do subsidies encourage overfishing, and are there current efforts to drive an agenda for a reduction in global fishing subsidies?
Yeah, so this is a question that comes straight into one of the things that occupy me and my group and collaborators like crazy. We've been looking at subsidies since the early 2000s, and we've built a database in support of the WTO negotiations to take out subsidies that are considered to be harmful to the environment. So yes, your question is right in there. It's one of the recommendations that have come up when I talk about broadening fisheries management. One of the key things is to take out the so-called harmful subsidies that lead to overcapacity and overfishing. And this is because it's a big amount. We estimate about $35 billion given out by our governments around the world to the fishing sector for all sorts of reasons. But a big chunk of this, 22 billion, encourages overfishing and overcapacity. So we are paying to take down our fish stocks and the future jobs and food of people. So the WTO is negotiating now to try to remove them. But they've been doing this since 2001 when they were given the mandate, and they haven't succeeded. Again, because of all the political aspects of this and the short-term, long-term dynamics. It's a big problem. If anyone wants to sign on one fisheries thing, this is the one. So contact your reps. They are negotiating now, and ambassadors at the UN and the WTO are pushing to take this out.
Okay, thanks. As we wait for more questions, I'll jump in with another one on the topic of food security and its intersection with forests and geoengineering and plastics. We've had a number of suggestions that using bioproducts from, say, forests or other terrestrial systems could be a way to absorb carbon dioxide, but equally could be a way to produce alternative, more biodegradable polymers, for example. But if we were to, for example, convert large tracts of agricultural lands into the production of, say, bioethanol or something like that, there are potential challenges around food security. And I wonder if Douglas, or in fact, any of our panelists would like to comment on that intersection.
I can start by just pointing out that one of the first ideas that had been pointed for CO2 removal is this thing called BECCS. So bioenergy with carbon capture and storage. You grow plants, you burn them in a power plant, you suck the CO2 out of the flue gas. And of course, as the plants grow, they pull CO2 out of the atmosphere. And so if you bury that CO2 somewhere underground, you now have both energy and negative emissions. And all the climate models trying to figure out how you would keep temperatures to 1.5 degrees or 2 degrees. If you give them this option of producing energy and pulling CO2 out, they'd of course say, great, that's what I'll do. And the problem is that you wind up needing to plant an area like the size of India to do that. And we've seen even today, the amount of biofuels we have has already caused challenges with competition for food and competition for water. So I think that's sort of an example of, you need an entire systems view. You can't just sort of wall off and say, oh, I'm going to talk about climate change without talking about the broader environmental issues surrounding that.
Yeah, maybe to add to that is that I really fell kind of out of love with bioenergy is when I realized that um, from an energy perspective, or an energy conversion perspective, that photosynthesis is about 0.5% efficient. So it converts about half the sunlight that hits that area into biomass. And that just seems like a really, not very attractive technology to harvest sunlight. So it would make much more sense to use non-agricultural land and collect sunlight with, say, the photocells, solar cells, and then you wouldn't have to use agricultural land for energy purposes. Since, as Douglas pointed out, I think the burden of just the food system on land, on agricultural land, is already sort of at a limit. So I'm not sure we can afford to add, in addition to making all our food, now also making all our materials and all our energy carriers with dedicated crops. I think using agricultural waste might be is a different story, but I'm not sure how much agricultural waste there is and how far that would go.
I think
Sally,
that might be a piece, but it's not gonna pull out the 30 or 40 gigatons per year of carbon that we're currently putting into, of CO2 that we're currently putting into the atmosphere.
So I'd just like to make a point about food security, and particularly in some tropical areas, there are local communities that really rely on forests for a good portion of their diet. And in fact, people with those diverse native forests tend to have a healthier diet and have health benefits from that local source of food. And when you get big conversions to agricultural systems or to plantation systems, that can result in considerable food insecurity for those local communities and for a less healthy diet as well. So there are just so many issues tied up with the use of local ecosystems and when those change for commodity products. And that would apply to bioenergy as well.
Okay. Well, I think we're getting very close to our allotted time, and wanting to stick to that time, I'll just wrap up with a couple of words, and I'll give the final word to our host from Dartmouth, who will share a few bits of information about some upcoming events, including a follow-up to this panel that's happening this Thursday. The last question, I think, was particularly interesting in really showing how complex these issues are. That's not a surprise to any of you, but we do tend, as humans, to focus on the things that we know and things that we understand. And so we have had a tendency over these last 5 decades and beyond to focus on problems from more insular perspectives. Let's just say that we can solve a problem like cheap refrigeration through development of CFCs, only to open a whole other can of worms in terms of the impacts on atmospheric chemistry. Similarly, the development of biofuels can solve certain problems while creating others. And that's why I think it's so important that we continue to reach across into different fields, to engage in conversations with language that's unfamiliar to us and ideas that are challenging and strange. But I think when we dedicate ourselves to those kinds of interactions that reach beyond individual disciplines, and when we do so with humility, I think we're on the right track, I think, to solving, or at least beginning to address, some of these very complicated challenges. So the book, in that respect, was really interesting and gratifying for me to do, and I'm happy to give the opportunity for Roland and Douglas and Sally and Rashid to meet each other and to interact with each other. And I'm also particularly grateful for all of you who have joined with us, and I hope that you can join us again on Thursday for a follow-up. And with that, I'll turn it over to Stephanie, who will give us some information on some upcoming panels, which you can see here. So tomorrow, Wednesday, and Thursday. Go ahead, Stephanie.
Thanks.